Hey everyone, as we gear up for this year's Black Hat and DEF CON cybersecurity conferences, we're bringing you an episode from 2 years ago where we remember the works of a DEF CON legend and explain a few web browsing acronyms. We'll be back later this week with a recap of what we saw at Hacker Summer Camp this year, but until then, here is episode 146, which originally aired in May of 2021. Welcome back to the 443 Security Simplified. I'm your host, Mark LaLiberty, and joining me today is...
Corey in Morning Knockreiner.
Yep, you will see why in just a little bit. We are both very sad today. Before we get into that, or after we get into that news though, we'll talk about a supply chain attack against a popular enterprise-grade password manager, and then dive into the world of same origin policy and cross-origin resource sharing, which I'm sure everyone would love to listen to on this morning.
I need a CORS. I think you need to add an extra O to it, but I definitely need a CORS.
CORS. I would like
Actually,
a CORS,
it's not my
please.
favorite beer, so I don't even know if that... No, thank you. I don't really want a CORS.
Please, everyone send cases
Light
of
or
CORS
otherwise.
to Corey. So let's start this week actually with a bit of sad security-related news. Just a week ago, the world found out that security researcher and penetration testing expert, and really just all-around good guy, Dan Kaminsky, unfortunately passed away at the age of 42. If you've been in security for long enough, like he is a staple at major conferences, Black Hat, DEF CON. Everyone's only ever had good stories to tell of him. And he's also just had some really major contributions to security as a whole in the industry. I guess, Corey, anything?
I think we'll talk about it in a sec, but yeah, I can't say I was a friend of Dan Kaminsky, but I knew him and interacted with him many times. We'll talk about probably one of his most famous findings in 2008, and I was actually in the DEF CON version of that presentation, standing room only. It was actually such a busy presentation. At the time, it was in Alexis Park, a really tiny off-strip hotel where DEF CON was, and the fire marshal actually had to kick people out of the talk. There were so many people in it. So I knew him from that. If there's any old-time Watch Guardians around here like Pop Corey, you might remember Radio Free Security, who we actually did interviews at that DEF CON Black Hat and had a roundtable, an audio roundtable, an old podcast that Dan Kaminsky was at. So met him. He's one of my kind of InfoSec geek gurus, someone I look up to. So very sad to learn, especially considering he's technically a couple years younger than me.
Yeah. And like you hinted at, he was probably best known for, back in 2008, he found the DNS cache poisoning vulnerabilities that basically, like, it was a massive expletive moment for much of the internet. To give some details on that, I mean, basically, so the internet revolves around kind of this delegated trust where you've got authoritative name servers out there that are responsible for resolving domains or pointing you towards where you can get a DNS record for a specific domain. So as you're browsing to google.com, if your DNS resolver doesn't know what that address is, goes and asks .com. .com points you towards a authoritative server, which eventually gets you down to Google, which eventually gets you to Google and its subdomains. And he found that on most DNS servers out there, you could actually inject falsified DNS responses into that DNS server's cache by basically all you had to do was guess a 32-bit transaction ID. So it's like 64,000 possibilities or something like that, which is, in terms of internet, is a very small amount of packets. And if you just blast away at a server with a bunch of falsified packets, you could potentially inject the incorrect IP address for any given domain name, which is bad enough for on like a domain level. Like if I could inject bankofamerica.com, that's pretty bad. It gets even worse though when you can inject an entire zone. So
yeah,
all of Google, all of whatever their authoritative zone is, could end up being pretty dang dangerous. And this is
Oh, sorry.
Go ahead.
I was just going to say, and this was essentially the birthplace of DNSSEC, something that Dan Kaminsky pushed in the industry for a long time. And while I don't know if he's the one that made the protocol, he was a very strong, staunch supporter of DNSSEC because of this.
Yeah. And basically, he discovered this in early 2008. He knew he was going to talk about it at Black Hat and DEF CON, and he actually worked to pull together a summit of a bunch of like the major DNS vendors out there, like Microsoft and the like, in order to get this patched as quickly as possible. They ended up doing like a bit of a workaround where instead of relying just on the transaction record, so 32 bits of data, they combined it with the source port as well. So now you needed 64 bits of data, which changed it from, cracking or being able to brute force it or guess it in seconds to potentially hours or days, which was a good enough mitigation at that point to make people feel a little bit more safe with it. But it was still a major issue in just the underlying fabric of the internet. And like you said, led to the birth of DNSSEC now to authoritate DNS responses.
Yeah. So, anyways, Kaminsky, I think we're all sad to see him pass. He will go down in internet security history. And I want to comment, even in my small talks with him, beyond just his contribution, he was just such an all-around good guy. I mean, anyone that talked to him knew he was just a very nice guy, very eclectic the way he spoke, very unique person.
Yep.
So I think everyone's very sad to see him
Sad
pass.
day for the internet. Rest in peace, Dan. And your contributions will not be forgotten to this industry. So moving on now to some news out of just last week. So last week, Click Studios, which is a developer of a pretty popular enterprise-grade password manager called Password State, published an advisory stating that any customer who had performed an in-place upgrade between April 20th and April 22nd potentially downloaded a malicious upgrade file. This is pretty big news when it comes to a password manager. They actually have a pretty decent adoption rate. I think I saw something like 30,000 customers or so, many of them Fortune 500 companies. It's basically like a normal password manager with a lot of administrative tools for admins to help manage passwords across a large enterprise. And so when you see something like this, where there's a supply chain attack against a major password manager like that, it tends to be a little scary. One researcher, Taha Karim, actually managed to get a hold of the update file and did an analysis, which he posted on his blog. Went through step by step exactly what's going on with the malicious update. Basically, it was a compromised DLL, so a compromised library, that calls home to a hard-coded command and control domain, and then downloaded and decrypted and executed a zip file that it got. And that second stage didn't actually last for very long. I think the infrastructure got taken down pretty quickly, like by the end of April 22nd. But they managed to get a copy of that second stage that it downloaded, and they could then see exactly all the bad things that this update tried to do. It's basically everything you expect from a supply chain attack against a password manager. Like, it grabbed info on the user, like the computer name, the username, and user domain. Got information related to password state itself, so it can connect to a proxy. It would grab its proxy username and password. And then, most frighteningly, it actually was able to get all stored passwords from password state in plain text by basically abusing the built-in
for that
APIs.
affected user.
Yeah.
But still horrible.
Yeah.
Now, and there have been, I still do recommend password managers. There have been password manager vulnerabilities before. I even recommend ones that have a encrypted cloud store that the vendor can access. But the good news, at least in the past ones, is it was, I'd never, at least for the one I use, seen a vulnerability where they could actually get all your passwords. Because this is actually malware running on your computer, the fact that it gets all the passwords is a really big deal.
Yeah. And not
By the way,
even...
I know that this is actually a well-used one, but I have to admit I had never heard of it.
Yeah.
It's not among the ones I consider the top ones.
And with this specific incident, it's not even that it was malware running on the computer, it's that it's malware running in the context of the password manager itself, which gives it access to these password bundles. Like, yes, malware on computer could potentially scrape memory and
Yeah.
look for passwords or
But this is
encryption
from the
keys,
legitimate program itself,
which gave it
with the
full
down.
access
Yeah.
to all of the built-in APIs inside of it to then just retrieve whatever passwords it wanted. So like you said, like I too, I'm still a big advocate for password managers. In general, like they're pretty dang secure, even though these cloud-based ones do technically have a encrypted bundle of your passwords up on their servers. Like, barring a supply chain attack like this, even if an attacker managed to get that bundle, as long as you have a strong master password, they're not going to be able to break into that in general. But with that said, this is one of the risks. Like,
Yeah, the supply chain is a whole different story.
yeah. So, I mean, what's your advice on this one, Corey? Don't trust your password manager anymore either.
No, I do think, I mean, the prediction we made years ago about supply chains was just a few years early, because I think you all know that this seems to be the smart avenue of sophisticated modern attackers. We're going to have to find a way as an industry to really validate stuff even coming from the trusted source. I will say, like, this is a horrible issue, but if I were to give them a little kudos, the one good thing is it only happened. The malicious down upgrade file only happened between April 20th and April 22nd. Like, if you look at the SolarWind attack, they were unaware of that for months. There were many versions of their Orion Studio installer. I'm sorry, the SolarWinds Orion installer. I think it was over a 6-month period that any version you got was still infected. So if there's any silver lining, if you didn't download between those 2 days, kudos for them for figuring it out quickly. Although I guess quickly would really be within minutes or not at all. But still, it's better than the worst case supply chain attack that sometimes you learn about a year later.
Yeah, I mean, they were quick to identify it. They've been really transparent with their response, which is one of the things I always say about password managers. Like, security incidents happen. It's a thing. It matters how they respond and what they learn from it. And in this case, like, you have to hope this isn't a mistake that they'll make twice when it comes to
Yeah.
pushing
They seem
out.
to be reacting to it okay.
Yeah,
But if you do use password state, at the very least, if you downloaded within those days, you need to change every password now and probably audit some of your accounts logins.
yep. So moving on out of the news now, a few weeks ago, we started this series of talking about what I like to call solved security problems for web apps. Basically, things that, as you say, are academically solved, like cross-site scripting or SQL injection, where there are defenses that developers can enact in order to protect against a lot of these really common web app flaws. We talked last time about cross-site scripting and some of the protections for that. This time, we're going to be talking about same origin policy, cross-origin resource sharing, and how they protect against cross-site request forgery attacks. So, a lot to unpack here. Yeah, I guess we can just start at the beginning and give a little bit of overview of what happens inside your browser and some of the avenues for attack in here. And basically, if you've ever loaded up your browser's developer tools and visited a website like CNN.com, you're going to see that in order to load that just CNN.com homepage, your web browser makes a lot of requests to a huge number of domains. Now, you'll get CNN.com for just the page, bare bones code, cdn.cnn.com for some of the data on it, www.i.cdn.cnn.com for the fonts, and then multiple third-party domains for advertisements and analytics, things like Google Analytics, Facebook, because they track you everywhere you go on the internet these days, it seems like. There's a lot going on behind the scenes in your browser. And this is normal on the modern internet. Like, most web pages load up resources and make requests to a variety of domains. It's not like
I think I would even go as far to say it's rare to find one website that doesn't have at least one totally other domain. Not even a different origin in the same subdomain, but even very clean websites tend to at least talk to one other domain for some reason or another.
Yeah, I mean, this has been the case for quite some time too. Like, even back in the old days, like I remember my GeoCities websites I'd set up. Like, even then, if you're hosting a pretty dang flat site, you're still probably loading like a JavaScript library from some Google CDN at that
Yep.
point. So even then, it would be making a cross-domain query. And throughout normal use, your browser will make these variety of request types as well. So in HTTP, there's a few more common methods. There's actually quite a few methods, some being very uncommon that you don't see that often. But for example, like a GET request is how your web browser gets content from a website and APIs, like the
Give me
page.
something to show this person.
Exactly. Images, fonts, data, all of them, it'll submit a HTTP GET request to a specific resource and then gets the data back from that resource.
Or a 3D rendered WebGL texture that I can put on this cool model for my web game.
Or a Pokemon sprite for my Pokemon FAQ website that I made back when I was 8 years old.
Awesome.
On top of that, the second most common one is probably a post request, which is how your browser sends data back to a web server or an API. So if you log into a website, it'll send a post request with your username and password. If you're buying something on Amazon, there's a series of post requests it'll send to add something to your cart or confirm your payment info, and then check out with your confirmation once you've made sure that you actually do want to buy that giant inflatable bouncy house or whatever.
And by the way, now that you know these methods, even this seems antiquated to talk about, but Mr. Pop Pop Corey, old timer, I remember Web 2.0, when Web 2.0 was a big thing in the 2000s, really. And that was, websites used to be just visual. It was all about getting and showing stuff. And so you can kind of consider Post as the beginning of Web 2.0, where users started sending information to websites, which sometimes affects, sometimes what you're sending is affecting what's shown back at you, such as a successful purchase or adding a forum response so other people can see what you have to say about their Reddit comment or Reddit meme.
Yeah.
So yeah, Post is
Exactly.
all about Web 2.0.
On top of those, there's others, like technically there's a delete, which you can use typically through REST APIs to delete some resource.
That's what I do with all of Mark's web content. He forgets to leave out that method, and I just delete his crap. I'm kidding.
There's
Keep
put,
going.
which is kind of like post, but it's typically used for putting like a blob of data. Amazon uses it, for example, with S3 buckets, where if you're uploading something to an S3 bucket, it's typically going to be a put request versus a post request. And there's many more outside of that as well. And as your browser makes these requests to get data or submit information or load up forms or submit forms, it includes any session cookies that it has with that request. So if I'm logged into Amazon.com and I load up some page on Amazon, any request it sends to Amazon will include my authentication session cookie with that request.
Yeah, that's what I wanted to remind people, that the cookie is just a piece of information. The website is asking to be stored on your computer to have some sort of state. And the most important part of the cookie is when you authenticate, there's usually a session cookie that is really your authentication. But the cookie can store all kinds of information about your state with that website.
But at a minimum, that session cookie will usually be like a long, randomly generated ID number, where now when your request comes back, if it includes that cookie, Amazon will check in its database and say, oh, that matches up with Mark the Liberty. They're authenticated. Cool. Let's go ahead and when they buy this thing, we'll stick it on their account. This can be a security risk, though. So imagine a scenario where an attacker tricks you into visiting a malicious website, so badguy.com. Either with a phish or with Google cache poison or search poisoning or something along those lines. If that website has some JavaScript on it, in the background, it can make a series of post requests to Amazon.com, for example, to add an item to your cart and to go through the checkout process and to finally hit checkout. With JavaScript, this all happens in the background. Like you wouldn't see anything going on unless you were monitoring your web traffic. And without any protections, these post requests then would use your existing session cookies as if you were logged into Amazon.com. That way it would be able to use your account to make all these purchases. It's just a feature of browsers where when it sends this request, it'll include whatever session info it has for that domain. This is a textbook cross-site request forgery vulnerability where...
Say that 5 times fast, Mark.
Cross-site request forgery, cross-site request... I give up. Never mind. I'm not even going to try. Basically, when a malicious domain causes you to make a request on another domain. And again, without any protections, that request will include your session cookies or any other authentication data as well. And it can cause you to do things without you even knowing that it's causing those actions to occur.
So just to be plain, if a cross-site request forgery vulnerability existed in all these places, an attacker could make you visit their link, and behind the scenes, their link could go to Amazon, do something like purchase something with your authentication, essentially.
Or go to your bank and drain your bank account.
Yeah. Granted, you would have to have those vulnerabilities somewhere.
Yep. And the good news is, though, there are protections against this built into just about all web browsers these days. So modern web browsers enact something called a same origin policy. And before we jump into what that is and what it does, we should start with just the word origin. And what is origin in the context of web browsers and web traffic? And specifically, it is the combination of the protocol, port, and host portion of the URL that you are visiting. So if I go to https watchguard.com, that is an origin. It's the combination of https, watchguard.com, and then the default port 443.
Or a 443 for HTTPS. Yep. Yeah.
If I go to https www.watchguard.com, that's a different origin.
And this is interesting, right?
Yep, because the host is technically different.
It's technically changed.
Even though it's a subdomain of WatchGuard, it is still a different origin at that point. If I go to https watchguard.com:8443, so a different port, that's also technically a different origin as well.
And by the way, if I went to foo.com, that's most obviously a different origin.
Yeah.
So I think a lot of people, sometimes we say cross-domain. Cross-origin is different. Mark just pointed out. It can include the same root domain, but in different ways. If it has different ports, different subdomains, it changes. But do know, of course, that normal, totally different domains also fall out of the same origin.
And it's just the port, protocol, and host. So the path portion of the web request can all still be the same origin, even if it's going to different paths. So like if I go to watchguard.com/buy right now and watchguard.com/maybe buy later, those are technically different resources, but they're the same origin because the port, protocol, and host are all the same. And
theoretically, all those files that make up those paths will be on the same machine.
Exactly.
Unless there's some sort of...
So same origin policy controls interactions between two different origins. So by default, your web browser actually blocks certain requests across origin boundaries. A good example of this is our Capture the Flag website, crimsonthorn.net. So we actually use...
Marketing. I thought we weren't a vendor podcast. I'm kidding. Go to our crimsonthorn.net website. We're going to have a cool CTF soon. Yep. Keep going. Sorry.
So because we do not trust Mark to write a authentication library, we actually use Auth0 to manage authentication on our CTF website. So when you log into crimsonthorn.net, the post request that includes your credentials actually goes to id.crimsonthorn.net. So a subdomain of it that is technically a different origin. And because this origin is different than the original like crimsonthorn.net, it's technically different, which means by default, your web browser will block this request. So if I had just set this up without any other modifications to some of the things we'll talk about in a second, if you tried to log into the website because the post is going to a different domain and origin than the actual crimsonthorn.net, it would get blocked.
But you fixed it. You just put a wild card there, right? Just I'm kidding. Keep going.
Yeah. So this default behavior is good. Because it prevents many cross-site request forgery attacks, like that Amazon.com scenario, for example. But if you go through
in other words, let's say we suffered some flaw and we didn't. We had, let's say Auth0 was a bad guy. We really never intended to run any script or post anything to any pages there, but it was something injected in our site. That would be bad. And that's why it's really good to have this policy so that even if someone can take advantage of a flaw to change your web code, they would have to do a number of things to defeat this and to get code from other origins to run.
Yep. But if you were to go to that website right now, authentication succeeds. It all works. So why is that? And it's thanks to something called
wildcard.
Cross-Origin Resource Sharing, or CORS. That's where that comes in. So
Cores. I like it.
Corey's
It
cores.
sounds like I own that.
So web servers and APIs on the internet can use special HTTP response headers to tell web browsers that it's okay to override the same origin policy. There's quite a few different headers that fall into this, but the most important one that we'll start with is called access control allow origin, which contains a list of origins that are allowed to make a request to that resource. So in the case of id.crimsonthorn.net, its access control allow origin header is set to https://crimsonthorn.net, meaning that that specific origin, so our main CTF website, can make a cross-origin post request to id.crimsonthorn.net. If that header wasn't there, your web browser would not send that request, it would block it, and you wouldn't be able to log in. Now, we have it set to a specific origin, which means that only traffic originating from crimsonthorn.net can make a post request to our login API.
Aw, you're too smart for my wild card.
That means if I was on badguy.net, I couldn't use JavaScript to try and log into our CTF. But some developers take the easy route and instead set the access control allow origin header to just a wildcard, an asterisk, which allows these legitimate requests to succeed, but it also disables protection against malicious origins doing the same thing.
We might get into this a little later on other ways you can, but besides the wildcard, some developers maybe they have a number of origins that they do want to allow, and sometimes the easy route to do that is write special regex. Maybe they're all in the same domain, maybe they're different subdomains, so rather than having to list them out, maybe use regex or something. So another common, besides using a wildcard, another common thing is maybe messing up regex to be overly permissive or something like that, maybe forgetting a certain character. And sometimes people, if you're not careful with how you kind of set up this access control allow origin header, you can have some trouble.
Yep. Along with that access control allow origin header, there's plenty of other ones too. So another one is access control allow methods, which a web server or API can use to restrict which request methods a browser can make, like get or posts or options. So for example, if I'm hosting something on id.crimsonthorn.net and I only want to allow get requests, I would set that access control allow headers method to just get. And if someone tried to post
I only let Mark get from my side. I never let him post. No, thank you.
Exactly. And if that were the case, the browser would not send the post request. It knows, okay, this doesn't match the policy, so I'm just going to block it right here and there. The same origin policy also restricts which HTTP headers are allowed by default to protect against sending session cookies without explicit permission, for example. So the core's access control allow headers header tells the browser which headers should be allowed. So like if my session cookie is stored in like a header called x-auth, by default, that would be blocked unless I explicitly allow it with this cores header. Finally, the access control allow credentials header tells the browser whether or not credential cookies, like cookies or basic HTTP authentication, should be sent with requests. So, for example...
And you often want this, right? Because sometimes you do want to make sure only authenticated. Like if I had... Amazon.com, someone was making a purchase and I had purchase.amazon.com. I would want to make sure the person that was doing this cross-origin request was already authenticated to Amazon.com.
Exactly. But there are scenarios where you wouldn't want that. That's why you have to explicitly allow it as well, because browsers will default to the safer of just denying it unless it's allowed. So in some situations, it isn't even safe to allow that initial request without first checking that it's safe. So like it might be dangerous to attempt to send a post request to Amazon.com or bankofamerica.com. Now, even if that server ends up blocking it due to the origin, you might not want to even send it in the first case. And so in these situations, the browser will trigger what's called a CORS pre-flight request. So if you open up your web browser's developer tools and watch the network traffic as you browse around the internet, and like log into different pages or do different actions on sites, you're going to see a lot of these CORS pre-flight requests go out. They get fired off all the time. And basically how they work is before your browser sends the actual request that it wants to do, it builds and sends a HTTP options request with some specific information. So it includes its origin, so crimsonthorn.net on HTTPS. It includes the access control request method header with the request method that it wants to use in the actual request, like posts. And it sends in access control request headers with the headers it wants to include, like auth0 client or content type, for example.
You're being very technical and specific about it, but put another way, it's like, hey, buddy, here's where I'm coming from. Here's what I want to do. And here's how I've authenticated if needed. What can you tell me?
Yeah. And the server will then respond back to this request and sends its own CORS policy via those headers that we mentioned just a little bit ago. Like it'll say, oh, hey, what's up? Yeah, so here's my access control allow origin saying that, okay, are you allowed to send this request from crimsonthorn.net or not? It'll say, okay, what about request methods? Will I allow a post? Sure, sounds good. Headers, credentials, all that. It's basically a way for your browser to check with a website if it's allowed to send this request before it actually sends it with all of the information like your username and password and all of that. And your web browser is in charge of enforcing all of these instructions. Like your browser knows to check that the origin of the request it wants to send, check it against a list of allowed origins returned by the server. And if it isn't on the list or it doesn't match a wildcard, it will not send that request. And instead, it just displays an error back in developer tools saying blocked by same origin policy. So CORS and same origin policy, they actually have some benefits outside of security also. Like these are all obviously to protect against things like cross-site request forgery attacks, but can also be used to control who's allowed to access some of your content. Like web fonts, for example, fall under CORS and same origin policy, where it allows a web server to host a font, but then restrict access to using them to only specific websites that are permitted to use them. Same thing with WebGL textures.
And even specific websites with authenticated users, even if you
exactly.
wanted.
So like, let's say I made this really sweet font file and I want to sell it. I could host it on my site on a CDN and then use CORS to then control which websites are allowed to use that font within their website. And browsers will block access to them if that website isn't a part of the CORS headers returned. But like that said, this is still a pretty technical protection, and it can cause a lot of issues for web developers too. Like only the web browser developer console will share information on why the CORS request was blocked within the application code itself.
This is very interesting in that when something isn't allowed for a security reason, this mechanism was designed to not really share anything but an error.
Exactly.
There is an error, but it's not detailed in any way.
The
really.
JavaScript inside my website doesn't know why it was blocked. It just knows that it was blocked. And that's to protect against potential privacy leakage or security leakage by giving it any more details than it absolutely needs to know.
Which is smart.
Yeah.
But I guess when you're debugging could be hard.
Exactly. Origins can also be sometimes difficult for developers, which is why more often than I care to admit, many of them do just use a wildcard instead of having a more restrictive cross-origin policy for their sites.
That's my wildcard joke. Unfortunately,
exactly.
Mark's too smart for me and doesn't just use wildcards.
And CORS and same policy origin aren't appropriate in all scenarios, though. Like, for example, if you look at the web traffic when you manage your WatchGuard Firebox through the web UI, sometimes you can actually connect your WatchGuard Firebox up to what we call Dimension Command, which is like a virtual server for both monitoring and visibility, but then also some management aspects as well. And because that Dimension Command could be hosted on any number of custom subdomains that like we don't know when we build the platform, we don't know where you're going to host it. We actually have to have a pretty unrestricted CORS policy on the Firebox web UI to allow you to make management requests from your Dimension server, for example. The good news is there's other protections to kind of fill in those gaps as well. Things like cross-site request forgery tokens, which I think we'll talk about in a later episode in more detail. But basically, it's just a token that gets randomly generated that has to be included in all future requests to that web server. And because of the way they're delivered, so they come in through the web body itself instead of headers or anything like that, makes it really difficult for JavaScript on a malicious domain to access it and then get past these CSRF protections. But Cores and same origin policy do a really good job of blocking cross-site request forgery attacks, though. They're another technology available to help web developers with some of these threats. That said, like there are still some ways to circumvent it, especially if you're not using HTTPS. Because again,
Yeah, and
you want to hop on that
I
one?
think a good that's I think is a good thing to talk about, Mark. Cores or cross-origin resource sharing. This mechanism is great for security, but let's talk about it being bypassed. Can it be bypassed? And the one thing, even not already knowing the bypass methods, the one thing that comes to mind is this is all headers. While there is one header to ask whether or not you're going to share a cookie for a credential, there's no real authentication happening between the server client relationship within these two origins. And that means if I'm a man in the middle, I could alter headers, whether it's from coming from the client origin or coming back from the server origin. So what are like the mechanisms are there mechanisms to bypass this? Is there, I can imagine things like cross-site scripting. If the server and the code on one of these origins had a flaw, like for instance, if I know that Amazon.com to go to payment.amazon.com has cores, but I can find a cross-site scripting flaw just on Amazon, I might be able to leverage that cross-site scripting flaw to start to send these requests with that origin of Amazon.com. So that's
Exactly.
one way I could think of. But are there other things, if I can, assuming HTTPS isn't the issue,
Yeah.
anything else you could do with that?
Like if you can man in the middle of the connection, you can modify that origin header. So like I could have a website, badguy.com, and if I'm man in the middling it, I could change the origin to say, okay, actually I'm coming from Amazon.com in this case. Now it wouldn't be enough to control traffic like on badguy.com. It would have to be the traffic between the victim web browser and the actual Amazon.com
You have to get the
destination.
response.
And again, doing that in a world that is heavily encrypted with HTTPS these days is exceedingly difficult, but it's just yet another reason why HTTPS encryption is so important for security.
And that said, do you know, though, that if you are a web application vulnerability tester or hacker, you're looking at lots of ways to bypass this. And while that man in the middle is one option, the other options probably tend to do more with the misconfigurations. The simple ones like a wildcard, which is pretty bad. But do maybe in another episode we'll talk about them, but there's sites there that talk about very common CORS misconfigurations. I brought up one before with using regex, maybe a mistakenly over permissive regex or not having a perfectly clean regex. So you really do have to pay attention to how you set up your cores. And I think a lot of the problems just come with sometimes the webmaster that's the one coding this doesn't necessarily know all the security ramifications of little mistakes. So do you know there are ways bad guys have figured out how to sneak past cores, but most of them do have to do more with bad configurations.
And I will say, like, if you are a web developer, you're in charge of setting up some of these cross-origin resource sharing scenarios. If you do have questions on this topic, check out Mozilla's documents. I think it's like developer.mozilla.org. They've got really good, easy to follow, easy to understand documentation on what CORS is, what same origin policy is, how it works, and how to implement it securely on your site. Like that's what when we were setting up this capture the flag website, that's what I had to go reference to figure out, okay, why the heck isn't this working and what are all these dang headers I need to configure? But
Yeah, and I will add to that. If you're curious, go to Detectify. I can't promote their product, but they're a product that kind of helps scan web applications for security. But because of what they do, they actually have some good pages on cores man in the middling, regardless of HTTPS2, and of course cores misconfigurations that cause security. So check out Detectify and just search for cores, and I think you'll find some cool stuff.
yep, plenty of resources out there, which is why like we like to say it is a solved, at least academically, security issue. There are tools and protections and things you can do in order to protect against a lot of these web app flaws that we see constantly being targeted, and like even our own data from the Firebox feed, for example, in our security report. So if you are a developer, it's just a matter of knowing what tools and protections are out there and not shooting yourself in the foot by misconfiguring them when you set up your website or your web app. Hey everyone, thanks again for listening. As always, if you enjoyed today's episode, don't forget to rate, review, and subscribe. If you have any questions on today's topics, suggestions for future episode topics, or maybe you just want to let us know about another web app security thing you'd like us to cover, you can reach out to us on Twitter. I'm at XORRO_. Corey's at SecAdept. And the both of us are at hashtag the 443 podcast. Thanks again for listening, and you will hear from us next week.
And don't forget to allow the delete method in all of Mark's origins.
Can we just delete Corey already?